Okay, so I'm going to give you a brief overview of my journey with the global neuronal workspace model of consciousness. And I can say from the start that it's actually a collaborative journey, and I want to straight away acknowledge my current team, who has established a fan zone in the middle there. Thank you very much. And my former teams, and obviously my collaborators, among whom Stan Dehaene, of course, with whom it all started for me. And it was 20 years ago that I was a PhD in your lab, and it really all started for me. And that's a drawing by Philippe Pinel during my PhD defense, where we apparently performed a doctoral transformation. I have plenty of those, I'll show you. They will be my birthday present to you. Okay, so it all started with this PhD. And at the time already, we were interested in what distinguishes conscious from non-conscious processing. We've been hearing about that already quite extensively. And we used a very nice protocol that is called the attentional blink that allows us to present a visual stimulus, for example, a word, and for exactly the same presentation of this stimulus, sometimes people see it very well, it's conscious processing, and sometimes they say it's not there, unconscious processing, same stimulus. So what happens in the brain in these two situations, what we observed was very clear. We first saw that both situations had early sensory processing that was the same, exactly the same, until 250 milliseconds. After that, we had a bifurcation, following which only in the seen situation, people had a global activation of their brain, whereas in the not seen situation, we only saw local activations. Okay, so that was very straightforward, and our interpretation within the global workspace framework was that initial sensory buildup of the representations is pre-conscious. And what happens when we become conscious is that these representations get broadcast to a wider network of areas, a global workspace. Okay, this could have been the end of the story. Fine, we have the neural signature of consciousness. But it was not, because as some colleagues rightfully noted, it could be conscious access, but it could also be decision-making. Indeed, in these experiments, people make a task on the stimulus. They judge whether they had seen the stimulus or not. And on the other hand, there is also controversy regarding these initial activity. Are they really pre-conscious, or is there already some conscious perception occurring during this sensory buildup? Okay, so that really summarizes one of the main endeavors in the field currently, as you've seen in previous presentations. Try to find what are the core mechanisms of conscious access independently from initial sensory activity and from decision-making. And this has been at the heart of my work, and I'll show you some of the results we got and how I think it might help us update the model. Okay, so first, how do we disentangle conscious access from sensory processing? Well, we've developed a protocol in which we managed to desynchronize the moment where you become conscious of a stimulus from the moment of the sensory buildup of the stimulus in sensory cortices. And that's a phenomenon that we called retroperception. I don't have the time to go into details, but basically these studies suggest that indeed all these phases of early buildup of the sensory representation might be genuinely pre-conscious. Okay, other side of the story, how can we disentangle conscious access from decision-making? For that, we started to test the generality of bifurcation dynamics. And I let you think about that while I'm having some water. So we had found these bifurcations in the attentional blink, but is it a really general property of the dynamics of becoming conscious? For that, we went for a very different protocol than the attentional blink, which was audition at threshold, very simple stimuli, and with and without a task. And basically, people were listening to vowels, A and E, at 6 levels of intensity around the threshold. And people came for an active session where they had to report the vowel and say how well they heard it, or a passive session where the vowel was completely irrelevant. And we were looking for these bifurcation dynamics, that is, brain activity in which we would see not only that activity across trial increases with increasing stimulation strength, but also that at threshold, we might see a split between 2 types of trials, some corresponding to non-conscious trials where the process is actually not triggered, and some corresponding to conscious processing. And a simple way to detect that in our data might be to simply look at the variability of activity across trials, because here we predict a specific burst of variability at threshold when you have 2 types of trials. So we're looking at that in our data. Okay, so do we see that first for active listening in our data? Well, we do for the late activations. So we have this profile that suggests that these late activations are sometimes triggered, sometimes not, when we're at threshold. And we can actually verify that if we plot the actual distribution of activity across trials. We see that there is a bimodal distribution for stimulation at threshold, okay? So does the presence of this late activation predict whether people heard the stimulus or not? If we're in the active task, so they actually tell us. Well, the answer is yes, very much so. Really? Okay, so if this late activation corresponds to conscious processing, we should still be able to see it in passive listening, at least when the stimulus is very audible. On the contrary, if it corresponds to decision-making, it should disappear because it's passive listening. And what we observed was neither of those options. We observed late activations for sure, but not the same topography, so a different waveform, probably a different network. Interestingly, late activations also here showed signs of bifurcations, meaning that sometimes these late activations were triggered, sometimes not, at threshold stimulation. So do they predict whether people spontaneously became aware of the stimulus or not? To test that, we introduced surprise questions. Sometimes we ask the subject after the trial, what do you have in your mind just now? And we predicted that if these late activations corresponded to conscious processing, when they are present, it could predict that people say that what they have in their mind is the sound. And indeed, it was predictive of this mind-wandering content. Okay, so that's interesting because it means that maybe this technique allows us to find signatures of conscious processing with no a priori on the topography, on the type of network, or the latency of these effects, and no need to collect participants' responses. Okay, so can we find what are the networks for these active and passive conscious access? We used fMRI, and during active listening, we see a beautiful global workspace with auditory areas, but also frontal parietal areas. During passive listening, it's a different network, but it's also both auditory and frontal areas, insular cortex, etc. So it's still a global network that might be a global playground. So a global network of areas that is circulating this information, but for no particular purpose. And the difference is the task-related network. Okay, we can go into more details by using intracranial recordings. And here we performed a clustering analysis that allows us to find clusters of electrodes that respond in the same way to our stimulus. And it gives us 3 clusters. The first one is very evidently a sensory cluster. And we see that it's still active in the passive condition. The last one has a nice ramping activity with sites in planification area. It must be linked to the decision. And indeed, in passive listening, it's abolished. And we have this interesting middle cluster here that responds in an intermediate time, and that includes electrodes in the auditory, but also frontal cortex, insula, etc. And this cluster still responds during passive listening. So this might be our grail. This might be the network of spontaneous conscious access. And indeed, if we split activity across heard and not heard trials, this network has an all or none response to hearing the sound, even during passive listening. Okay, so this might help us updating the global neuronal workspace proposition. So far, we had been focusing very much on the control network here. But if we look at the more recent literature on the brain connectome and the connectivity in the brain, actually, global hubs in the brain seem to include not only the control areas, but also convergence zones with default mode areas, attentional and limbic areas. So can we redraw the classical global workspace draft to take that into account and plot the different networks more specifically? So that's what we do here. And we include in this global broadcasting core limbic and default mode areas. And on this setting, the global workspace seems to be a functioning of this global broadcast that flows the information or route the information preferentially towards decision-making and task execution. But there might be other ways to broadcast the information that give rise to global playground where a more exploratory cognition maybe is happening. Okay, so a while back we made model simulations where we showed that this type of architecture with long-range feedback connectivity showed spontaneous bifurcations when we stimulated them. And more recently, we show that also realistic macaque connectome using recent knowledge about the connectivity, the specific connectivity in the macaque brain, also show bifurcation dynamics in certain ranges of parameters. So finally, can we use this knowledge to diagnose consciousness in patients that are unresponsive? Well, we performed a first experiment using the same protocol with patients in collaboration with Lionel Nakache. And what we found is, first, for the early sensory response, in all our patients group, we saw a diminished sensory response relative to conscious patients, suggesting that already at the input response, there might be a problem. But importantly, what made the difference between minimally conscious patients that seemed to show signs of consciousness and vegetative patients was the presence of this later sustained activity. So now the big challenge is to go beyond the effect of the group and be able to diagnose individual patients, and that's what we're trying to do by fitting a simple version of the model to individual data. And with that, I'd like to thank you for your attention, and thank again Stan for exploring the global space and making me discover the global workspace. Thank you very much.